Well, good evening, YouTube. It's dark outside, which means it's time to make YouTube videos about obscure antique lighting. What you're looking at right here is about 1910, give or take, General Electric focusing flaming arc lamp that was known as the Boston Flame arc lamp, as it was used quite a bit in Boston around 1910. And this particular arc lamp is a culmination of all of the things that they learned about how to make arc lamps better. So basically what I'm trying to say, this is the apex of arc lighting, and I've been kind of hesitant about making the video because I haven't discussed the different types of arc lamps, the enclosed arc lamps, the open arc lamps, flaming arc lamps, luminous magnetite arc lamps, so I'm going to try to basically go over the focusing aspect of this particular arc lamp and then what makes this a flaming arc lamp. So this being a flaming arc lamp, it uses special carbons that have a center core doped with metallic salts, lithium carbonate, chrome oxide, things like that, that will contribute to the luminous efficacy of the arc. So here's a normal carbon right here, and you can see how at the tip of this thing, it's completely solid. This carbon rod is a 1/2-inch carbon rod with nothing but 100% carbon in it. So sometime, if you look at the trade journals around 1907 or so, these flaming arc lamps start popping up. And can you see the center of this carbon here, how it's a different color? Right there, it's a little bit darker. This is a cord carbon. And that center piece is carbon impregnated with metallic salts, and that increases the light output of the arc. So traditionally, like in some of my other videos, I've stated that on DC arc lamps, about 80% of the light comes from the 5,000 degree superheated crater on the top carbon. Well, you've got that going on here, as well as the arc stream containing those metallic salts, which dramatically increase the light output. And the salts that are in that arc stream are not too dissimilar to what occurs in a metal halide lamp. You're taking a mercury vapor bulb and then adding metallic salts to the arc stream to increase the light output. So that's what they were doing here. So if we look at our little fancy smancy name tag here, it says Form-2 flame arc lamp, and the volt and the volt, it's nothing else is filled out aside from the catalog number, but you can see it's made by General Electric. And boy, is this thing complicated. So what makes it flaming is it uses the cord carbons to to increase the output of light. And then I also mentioned that it's focusing. So what does focusing mean? Well, first of all, we need to understand what the problem is with the predecessors. So here's Mr. Adams Bagnall right here. This is our old enclosed carbon arc lamp here. And what happens is on the traditional carbon arc lamps, the top electrode can move, but the bottom one is stationary and it just burns down. So as the arc lamp is running, the bottom electrode burns down, and the point of light where it's being made, the light source, changes from up here and slowly moves down, and it changes how the light is focused, which is somewhat irritating in specific settings. So going back to our lovely focused flaming arc lamp, we'll look at the mechanism there. So the problem is the bottom carbon's stationary and the top one comes down. So what they did to remedy that is they made a fancy mechanism here to where both the top and the bottom converge together. So as I'm pushing this down, there are pulleys and chains and little gears inside of here that correct the burn ratio, since one of the carbons burns faster than the other. And it adjusts the position of that arc. and the arc gap always stays inside of the focusing element here. And what this ring is that I'm pointing to is a refractory material. It looks like it's ceramic, and it gets covered with white deposits and becomes very reflective. But ultimately, this device here keeps the arc right inside of there, which focuses it so it's not flickering around or changing where the light source is. And it's a very steady white focused light. So this really is the apex of carbon arc technology, and all the complex devices you see inside of here were to correct all the problems and make it more pleasurable for the end user. So let's take a look at the catalog here that shows this ugly thing here with its actual case on in the glassware. This thing's about 3 feet tall, and it's pretty ugly without the casing. So let's look at the catalog and go over some things in that. All right, here's the GE catalog showing this Form-2 Boston Flame lamp. I just wanted to thank Charles Brush for finding this information and having this catalog and supplying this information to me. So if you look on the left there, you can see the fixture with the case on, the vitreous porcelain reflector, and the glass shade. Just to point out, at the very tip of that glass shade is a metal tip, and that actually has holes in it. And what makes this significant is that if you look at the top part of the glass shade, there's another metallic ring where the glass is attached to that has holes in it too. So what I'm trying to say here is that these holes on the glass globe allow air to circulate through the firing mechanism in order to get oxygen to the flaming aspects of the carbon. So, you know, you might think, well, aren't carbon arc lamps supposed to be enclosed and keep the oxygen off the carbons? Not necessarily. On flaming arc lamps, you need the combustion aspect of that cord material in the carbons. Because of this combustion aspect, the trimming time is dramatically shortened from the then industry average of approximately 150 hours down to 15. So you get about 4 times the light output on a flaming arc lamp at a seriously reduced runtime. So the most likely typical applications for this light fixture would be inside of a circus or a concert, or inside any event where there's a large amount of people, where they want an extremely steady, high quality light that is very, very bright for the amount of wattage. For a brief period of time, if you look on the very top, for a very brief period of time, this was the most efficient arc lamp made at that point in time. And I'm under the impression this was one of the very first flaming arc lamps as well to come from General Electric. So you can't see it in here, but the price adjusted for inflation would make this particular fixture about $2,700 during its time of introduction. Anything else? So now that I've talked about all those things, let's take a brief look at some of the main components. It's very complex, so I'm going to try to spare you all the boring details. The lifting coils are right here. The solenoid lifting coils are right here. This tape is on here because when I bought it, the seller didn't pack it very well, and the case rubbed against the wire and kind of damaged it. So I need to I've got the wire soldered, but I can do a better job and then possibly repaint these with Glipdol, which I'm really not wanting to do. I like to keep them as original as possible, but it just looks stupid with those little pieces of wire hanging out of the spool. And the counterweight mechanism, you can see one of the counterweights move right there. There is a pulley, can't really see it. There's a pulley up in there that adjusts, and then it also has another counterweight for bigger adjustments when the carbon gets really, really out of whack where it's supposed to be. It has this counterweight that moves the whole entire assembly up to keep the carbon. It's got 2 balancing mechanisms. It's very complicated and intricate. It's pretty cool. how it works. All the wires, they have these ceramic beads on them to deal with the high temperature and keep them insulated right there. And then naturally, here is the ballasting, the auxiliary ballasting equipment. It's a ceramic tube with nichrome on it. This is actually, they started using nichrome around 1910 or so. So I didn't have to replace this. It's completely unoxidized and in really good shape. If you need to change the voltage, you'd loosen this screw right here, and this entire ring right here would slide up and down so you could change the input voltage on this particular fixture. So really interesting design, very complicated, and probably wouldn't be too fun to work on in case something got out of whack or if you dropped it and bent something, because it is quite delicate and fragile. So that goes over all of the fun basic components on this Form-2 GE flaming and focusing arc lamp. So now the fun part will be to put some voltage on this thing and see how it behaves and functions. So here's my little lovely DC power supply right here. I'm gonna get the plug started, and then I'm gonna get my phone where it needs to be so you can see it start up. Turn the light off there, and here we go. So as far as arc lamps goes, this thing's pretty boring to watch. It doesn't flicker. The adjustment is downright perfect. And it's very quiet. That hissing that you heard was the water being driven out of the carbon as it is heated up to about 5,000 degrees Fahrenheit. And see the little focusing ring right there? And it just throws all the light down. I would say this outputs about as much light as a 250 watt mercury vapor lamp. It's points straight down. It's very focused. It doesn't flicker. It's just a very high quality of light. And you can tell that they really put all their technology into this thing. And it definitely shows. It's not very fun to watch. It's pretty boring. Yeah. You can see how the light's on the floor. It is interesting to note that General Electric in the trade journal, it does mention that for a brief time when this thing came out, when this particular fixture came out, it was the most efficient arc lamp for a very brief period of time, a few months. Yeah, so. Well, I hope you enjoyed this video and learned a little bit of something and found it to be informative. I find these arc lamps to be deeply interesting and just downright fascinating. So until next time, I'll talk to you later. Bye-bye.